Hey guys, welcome back. We've been doing some power factor practice, and I figured we should take up a couple from the homework. The homework was Unit 5, Handout 2, 3, and 4. This particular question is Unit 5, Handout 3. And the reason I want to take it up is because it is a parallel circuit, and we haven't actually looked at a parallel circuit. But it doesn't matter what the circuit looks like. If you do it the Van Andel way, you're going to solve them all the same way. You're going to solve them by calculating the current somehow. Basically, what you want is I total, and what you want is the power factor. Okay, equals, because the voltage has been given to you in the question, and if you can calculate the total current, then you can calculate the VA, and if you have the power factor, you can start a power phasor diagram. So this is a parallel circuit, no big deal. We know how to calculate the current in any circuit, and so that's how we're going to do it. And again, I've said this before, there is more than one way to calculate this. If you tried this and calculated it a different way and got to all the right answers and you know what you're doing, that's fine. I'm going to mark it correct when it comes to the test, okay? I'm just going to do it the way I always do these because it works for me, okay, guys? So unfortunately, this particular question is 40 microfarads, which means I got to figure out how many ohms that is first. So that's not a big deal, but we got to remember to do it. That ain't 40 ohms, okay? That's 40 microfarads. So real quick here, I'm going to calculate this. Okay, 2 times pi times 50 times 0.1234. Okay, so that's 79.6 ohms. Okay, now this is a parallel circuit, guys, so we're going to make sure that we do not use impedance phasor diagrams, right? It's going to be current phasor diagrams. We're going to add the 3 currents to get the total circuit current. So that's what I'm going to do here. Okay, so we calculated that, and now I'm going to draw a current phasor diagram that represents these. So this is going to be a kind of a goofy one here, guys. We're going to have a long IR. Two minus 1.508, 0.492 amps right there. And finally, that's going to allow me to calculate, I total, right? And I'm going to use Pythagorean theorem. So that's going to be that squared plus 4 squared equals root. Looks like the circuit current is 4.03 amps, okay? So 4.03 amps. And that looks like it's this answer right here, okay? Now notice that it's the last thing that it asks for, not going to be the last thing you're going to calculate it. You're going to calculate it first. The next thing we're going to calculate is the power factor for this circuit. You can use any legitimate phasor diagram to calculate the power factor, and it will always be the adjacent over the hypotenuse. So it looks like it's going to be 4 over 4.03. Okay, so we'll do that. 4 divided by answer. Looks like it's at 0.993. Okay, guys? Or maybe I'm going to leave it 2.5. just to keep it a little bit more accurate. All right. Now that we've done that, guys, we're going to draw our power phasor diagram. And it's going to look like this. And sometimes students worry or wonder, you know, is this upside down? Is it right side up? I mean, I drew this correctly. It's the right side up. Now I'm drawing this. Once you have power phasors, guys, it doesn't matter, you know, whether you draw it upside down or right side up. I don't worry about it at all. I just put power on the bottom here. I put VARs on the side here. I put VA over here. I put my power factor right here, 0.9925. Okay, guys? And we're going to calculate our VA. It is going to be 120 times 4.03. 120 times 4.025. Oh, no, 03. All right. Looks like it's 483 volt amps. All right. So this is the first thing I calculated after I calculated these two. Now I'm going to calculate my power. VA times power factor. Okay, guys. So 483.6 times 0.9925. I mean, this is almost running at unity, right? So times 0.9925. Looks like it's 480 watts. Okay, guys. And my VARs, which I'm going to calculate right down here. (483.6) squared minus 480 squared equals root 58.9 VARs. Okay, guys. So let's see. Power factor 0.9925. Power 480 watts. VA 483.6 volt amps. VARs 58.9 VARs. All right, guys. So solve this exactly the same way we've been solving the other ones. If it happens to have a voltage and a current that's given to you in the question, you know, thank your lucky stars. Calculate your VA first. Put your power factor in there, calculate these other two. If I happen to give you a circuit, you know, you're going to have to calculate the current yourself and the power factor yourself. And then you can proceed with the power phasor diagram. And like I said before, this is not the only way to do this. There are other ways. For example, I could have calculated VARs XC by multiplying this voltage times this current. Then calculated VARs XL, would have been this voltage times this current. Then calculated true power, that voltage times that current. And then I would have a phasor diagram that had three phasors. It would have, you know, the true power on the bottom, VARs XL going up, VARs XC going down. I would end up a little bit over here with VARs X, okay? And then I could calculate the sum of the three, which would be the VA. And maybe I'm going to do that actually, just to show you that that's the other way to do it. And if you don't like that way, or you don't want to hear about it, then look away. But here's what I could have done instead of that other option, would be calculate the VARs. Okay, after I calculated these three currents, okay, so you'd have to calculate these three currents either way, but then I could calculate VARs XC. It would be, you know, EXC times IXC. EXC is 120 because all the voltages are 120, so it would have been 120 times 1.508. Let's do that for a second. 120 times 1.508. Okay. Looks like it's 180.96 VARs. Right. Then I could have calculated VARs XL. It'd be 120 times 2, so that's 240 VARs. Then I could have calculated the true power. It would be 120 times 4. which is 480 watts. Okay, and then I could have started drawing my power phasor diagram, and it would have 3 phasors in it. It would be true power, 480 watts. It would have VARS XL. That would have been 240 VARS. Okay. It would have VARS XC. Would have been 180.96 VARS. Okay. And this would be VARS X, guys. And it would be equal to 240 minus 180.96. So 240 minus that, 59 VARS. Okay. And the VA would have been the sum of the three, so this line right here, and it would be, the VA here, would be the square root of 480 squared minus 59 squared, oops, plus, because I'm solving for the hypotenuse there, so 480 squared plus that answer squared equals root, okay, 483.6 VA. Now, that's the other way to do it. Now, if you look at it, it's give me all the same answers, okay? VA, 483.6, 480 watts. The VARS, which is, you know, the total VARS in the entire circuit, it's VARS X, 59 VARS, okay? 58.9 VARS. So everything would work perfectly by calculating the 3 powers and then drawing a power phasor diagram that way. Or, you know, do it the way I did it right here. Calculate the total circuit current and the power factor, and then start with your VA and carry on. All right, so 2 ways to do it. I do it this way instead of this way because it makes them all the same. You know, you don't have to worry about it. Calculate the total circuit current, calculate the power factor, calculate the VA, move on. But I'm not sure. Stick around for another one, okay?